Hey everyone, welcome to Sequence of Instructions. Thanks for joining me. I'm on leetcode.com. I'm about to do an easy problem. This one caught my eye because I was actually given this problem in an interview once before. I think it's also in the Cracking the Code interview by that, or Cracking the Google Code interview, some book like that. It was popular going around when I was in school. I'll just read the problem description here. Given a linked list, determine if it has a cycle in it, also called a loop. Follow-up, can you solve it without using extra space? I know this solution, or at least I think I know this solution. We'll have to see if it actually if it actually works. But yeah, I like this. I decided to do this problem. It's not going to be hard for me because I'm pretty sure I know the solution. But it's a really fun one. It's a really, when you solve it this way, if you figure out how to solve it this way, it's such a, I don't want to use the word ingenious, but it's like such a creative way to solve this problem. Alright, so here's the definition of a list node. It has a current value, it has a next value, and then we have this hasCycle function, which is going to return a Boolean given the head of some linked list. Now, if you're not familiar with what a linked list is, I think I've covered it in other videos, but really quick to go over it. It's basically a list node is really just a piece of data that points to whatever the next piece of data is in sequence. So it's often drawn as boxes, so it'll be like, here's my first value, and then it points to some other value, whoops, and it points to some other value, right? And they might point to nothing, and that would be the end of the list, so here would be your list. But it's also possible that this thing points, let's see if I can do this, back to, you can kind of see my arrow here that I drew. It's possible that an element points back to a previous one, in which case if you kept checking next, you'd get this loop. 3's next would be 2, 2's next would be 3, 3's next would be 2, 2's next would be 3, and this would be bad if you're trying to iterate through this list because you now have an infinite loop. And because linked lists, you only ever know what element you're on in a given moment, it's not immediately intuitive how to find if you have a loop, right? Because I could maybe have like a bunch of different elements in between, like hundreds of different elements in between before the loop actually happens, right? And so it'd be like 2, 4, 6, 3, 2, 4, 6, 3, with any number of elements in between, and that's kind of hard to find, to intuitively tell a program how to find. But we're going to go through it. The way, and this is going to be a spoiler if you wanted to solve for this extra space problem, the best solution to this is, that I've come across, is to have two iterators that just check the next element. One of them goes at regular speed, first element, second element, third element. The other one goes at double speed. So, well, this one's saying dot next, dot next, dot next. The other iterator is going to go next, next. So it's going to go from 1 to 4 to 3, right? And you'll know you'll have a loop if they ever point to the same element again. Okay? So let's get into this. I was thinking about if we could do it with recursively, or if we should do it in a loop. I'm sure there is a recursive solution to it, but those are a little harder for me to wrap my brain around. In the interest of keeping this video kind of short, I'm just going to do it in a loop. So like I said, we're going to have two iterators. One's going to go to each element, one's going to go every double. So let's define those. We'll start them both at the starting node. There might be a more optimum solution that starts them already jogged. I'm not sure. But I know it will work if you start them at the same node. And we'll continue to check as long as single does not equal double. So as long as they don't point to the same thing again, we're going to keep checking. If they do, if we ever break out of this loop, we're going to return we're going to return true, saying that yep, signal does equal double. In which case, they're pointing to the same element. There must be a cycle. Otherwise, we're going to check as long as there's a next one to check. And we'll say a next one to check. If not double out next, and not double out next, return false. So if our double counter ever can't get to another element, in this example up here would be it points to null. So let's say this is our double guy here. His next has something, but his next doesn't, points to null. There can't possibly be a cycle. We're going to return. Otherwise, we're going to move single up 1, and we're going to move double up 2. All right, so this dot next, again, how linked list works, dot next points to the next element. So single is going to just move up 1. If it was here before, it's now going to be here. Single is now going to equal this element. Double is going to do that step twice. So they both start here to begin with. We enter this loop. It's a do while, so we're always going to do it at least once. And we're going to check if there's no next, or if there's no next, or there's no next, then we return false. This should be an or. And it's going to check, so it's going to look ahead too. If either of them are nulls, we're going to say, nope, there can't possibly be a cycle. Otherwise, we're going to move single up to here. Double's going to go dot next, Double's now going to point here. We're going to check again. And believe it or not, this will determine if there's a loop, or it should if I did this right. There should be some way to test this, right? Isn't there like a test case? Not sure. I guess I could just try and submit it. Should I spend a little more time thinking about this? Well, what if head is already null, right? I guess I could check for that case. If not head, return false. All right, and then here we are checking for nexts. So yeah, this should work. Let's see. Accepted. How'd we do? Not bad. Not too shabby. How'd the winner do? So I'm actually curious to see how some of these went, but let me check these winners first. Let's look at a couple of these. Yep, we got that. A walker and a runner. Those are clever names. A walker going by 1, a runner going by 2. And same. They did the inverse check. So their while was what my if was, and their if was what my while was. I guess maybe that's a little bit faster, but I think they're probably about the same. And that's probably most of the solutions are going to be like this. Yep, slow and fast. Let's see what these, how these ones did out here. Did they? Oh, they also did slow and fast. Yeah, I'm starting to think LeetCode is just a little inconsistent with how they grade these. I think probably depending on the day, you might get different. You might get a different score based on like what their server load is like or something. But because these all look like, well, a rate out push. Okay. Anyway, worth giving it a shot. Worth checking these out. If I can find the link to the book description of this problem, I will, because they go into depth about why this works and it's big O and stuff like that. Otherwise, happy to hear how you did in the comments. Please leave me some notes, and I'll see you all next time. Take care. Bye.